Night Clouds, presented by Science at NASA. A series of upcoming rocket launches will create glowing white nighttime clouds visible from the eastern seaboard of the United States. June 20th, 2003. One night soon, people on the eastern seaboard of the United States might see some strange clouds in the sky, milky white, glowing, and twisting in the wind. The clouds will be man-made, created by scientists to study Earth's ionosphere, a layer of our atmosphere near the edge of space. 3 rockets launched from the NASA Wallops Flight Facility on Wallops Island, Virginia, will release a chemical called trimethyl aluminum, or TMA, into the air 90 to 175 kilometers above the Atlantic Ocean. TMA burns spontaneously in the presence of oxygen. The harmless byproducts of this glowing reaction will be visible from coastal Virginia, North Carolina, Maryland, New Jersey, Washington, D.C., and possibly parts of lower New York and Pennsylvania. The launches will take place between 9:30 p.m. and 5 a.m. on a night yet to be decided between June 23rd and July 10th. The time and date depends in part on clear skies at 2 of 3 special camera sites located along the Virginia and North Carolina coasts. Members of the public can keep track of the mission by calling the NASA Wallops Flight Facility Launch Status Line at 757-824-2050. A pre-recorded message will be promptly updated when launches begin. NASA will also have a website with text updates and live video of the launches during the mission at http://www.wff.nasa.gov/webcast. The clouds will allow scientists to monitor winds in the ionosphere, explains Gregory Earle from the University of Texas in Dallas, the lead researcher for the project. They will act as a tracer and allow us to view the winds at various altitudes over a period of time. This is important because of space weather. The ionosphere is a critical link in the chain of Sun-Earth interactions. Solar flares and radiation from sunspots break apart molecules and ionize atoms in Earth's upper atmosphere. This is how the ionosphere is formed. The ionosphere, in turn, affects such things as radio communications and global positioning system reception on Earth. The data gathered from this project will aid in our understanding of the relationship between the winds and ionospheric activity, says Earle. This research may one day lead to better forecasting of space weather effects on satellites, communications, and power systems. There will be 4 rockets launched, but only 3 will release TMA, the first, second, and fourth rockets. The third rocket carries only scientific instruments. The TMA will be released over the Atlantic Ocean at altitudes from 56 miles to 109 miles. The clouds will take about 4 to 5 minutes to form after the TMA release and remain visible for approximately 20 minutes. There will be about 90 minutes between the launch of the first, second, and third rockets. The third and fourth rockets will be launched about 10 minutes apart. The actual period between launches will be decided in real time as the mission unfolds. NASA has used TMA for decades as part of rocket studies from sites worldwide to study the near-space environment. TMA burns slowly and produces visible light that can be tracked visually and with special camera equipment. The products of the reaction when TMA is exposed to air or water are aluminum oxide, carbon dioxide, and water. Aluminum oxides are commonly used to combat heartburn and to purify drinking water. TMA poses no threat to the public during preparation on the ground or during release in Earth's atmosphere. This project is a NASA and multi-university effort. In addition to the University of Texas, students and personnel from Clemson University and Utah State University are participating in the mission. This story is based on a NASA headquarters press release. It's presented by Science at NASA. To find more Science at NASA stories on the Internet, please visit science.nasa.gov.
In this report, NASA confirms a decades-long operation of high-altitude experimental dumping of trimethyl aluminum aerosols with the effect of heating the atmosphere directly with TMA, a powerful pyrophoric compound, and indirectly by releasing CO2, a known industrial-age greenhouse gas identified as a major culprit in the global climate change crisis also known as AGW, or anthropomorphic global warming.